All right. So we're here at the Display Week 2025. Did you have some fun here?
It's great. I've been going to every SID annual international meeting since 1970.
That's 55 years.
And at the president's reception, I talked to various people, and I've been coming here longer than virtually anyone else, because everything I've ever done has been improved and based on networking. And in the display field, this is absolutely the best meeting to network.
It's one of the best things humans want to do, is display their skills or display their science, their research, to show off what you've figured out. But displays is like a way to communicate any information you want. It's like such an important technology, you know?
Yes. In 1967, I was famous for my thesis research at Harvard on magneto-optical properties of magnetic oxides. And as a result, I was approached to be chair of the International Conference on Magnetism in New York.
Magnetism, like?
Magnets.
Magnets.
And
magnets are mysterious.
Yes. And I was studying rare earth ferric oxide materials.
Do people understand the magnets or still not?
Well, one of the targets of that magneto-optics was we hoped it would be an important optical memory. And I made the world's most sensitive spectrometer, which could measure 1.625 seconds of arc rotation. That's a second of arc is 1/3600th of a degree. And it was extremely difficult work, but I was able to become famous as a co-author of this work. And I published a paper with my research advisor and with a guy who is probably the world's leading crystal grower of magnetic materials from Bell Laboratories.
So there's a lot of magnets in all these LCDs? There's magnetism?
Well, in the semiconductor circuits, there are magnetic materials and metals and all sorts of rare earth materials, which the US is trying to
So the rare earths are really useful?
Yes. Yeah. And at any rate, in looking for employment after finishing my thesis, I applied to all the major research labs in the United States. And I told them that I will do anything that's interesting, challenging, and important. But if they didn't have anything unusual for me to do, I would be glad to continue my work in magneto-optics. And the IBM San Jose Laboratory, research lab, one of the leading research labs in the world at that time, offered me a job in San Jose to construct my magneto-optic spectrometer in their laboratory and to measure the magnetic materials that they were creating. And that was probably the last thing I really wanted to do because my thesis research was very difficult. You have to take major spectra, and then you have to use a computer program to relate it to the electronic structure of these magnetic materials, such as the rare earth orthoferrites and rare earth garnets. But one of the labs that I interviewed was the Xerox Research Lab in Webster, New York, a suburb of Rochester. And there I encountered liquid crystals for the first time. I had never heard of a liquid crystal. I didn't know what they did, and they did an amazing demonstration. They coated a thin layer of liquid crystal, sort of the texture of light machine oil, on a Xerox drum, and they exposed an image on that drum, a document. And then they developed this by applying a uniform voltage to that drum. And then they showed me the image in the liquid crystal that they had created. And it was a beautiful color image, very striking. And you could look at this image and say whether you liked it or not. You could see instantly whether it was a beautiful image or not. And you didn't have to go through the complex computer measurements and computer programs to derive the electronic properties of magnetic materials.
So when you saw the liquid crystals, you said, this is cool, I want to work with this?
I said, this is magnificent. And a little bit afterwards, I accepted a job at the NEC Research Lab in Kawasaki, Japan. And in my discussions with them, I told them that I should either work on something they are an expert in or something that I am an expert in. And Dr. Wenehara, who was my prospective department manager, said, you will work on something we're an expert in, which were these propagating electronic domains in a semiconductor material. And after I saw the Xerox demonstration, I faxed Dr. Wenehara and I said, I would like to smear a liquid crystal on their semiconductor device and make a semiconductor addressed liquid crystal display. And they said, that is very interesting. We would like you to do that, but we do not manufacture liquid crystals in Japan. And we don't have any, we don't know anything about liquid crystals. So would you find out more about liquid crystals and bring some with you?
Nice. You bring it in the bag?
Well, in the notebook LM, it says I carried it in my suitcase. Actually, I acquired information about where to purchase liquid crystals in the US from Aldrich Chemical and other companies. At any rate, my first day at work, at NEC, one of the challenges was finding the lab, because in December 1968, there were no romaji, there were no English signs telling you what stop you were at. So I had to ask people on the Toyoko line where I should get off for Musashi Kosungi. Anyway, I found my way to work, and Dr. Uenohara called me to his office, and he said, the semiconductors that we were going to have you work on are not going to work out. The domains are too large, and it will never be an important device. And so by the end of the year, we will tell the person who is working on that to find something else. So it's better that you do not start working on these semiconductor materials. But you mentioned liquid crystals in your correspondence. So why don't you work on them? And that was the last thing I wanted to do, was to work on a strange material that neither they nor I knew anything about, in a strange lab where they spoke a strange language and had a strange culture. But I accepted the challenge, and I became famous for my work on liquid crystals at NEC, because I discovered a new color change effect. And I wrote that up, and that was the first physical Physics Today article ever published by NEC.
The first what article?
The first, trying to remember the Physical Review Letters. It was the first article. It was a very prestigious journal, and it was the first time anyone at the NEC Research Lab had published an article in that journal. And the basis for this, I was able to get a room temperature cholesteric material, which had been the basis for work at Westinghouse in the United States. And when I tried to reproduce the Westinghouse experiment, and I applied a field to this material, at first it formed a multi-domain image with many scattering domains, and then as I increased the voltage, the color changed from blue to red, which was just the opposite of the effect that the Westinghouse people had published. Their material their colors went from red to blue. So I got just the opposite of their effect. And that was the second thing that had gone wrong. The first thing was the semiconductor in the lab had domains too big. And my first experiment, the color change went in the wrong direction. And so I scratched my head, and I decided the reason it went in the wrong direction was I was orienting the liquid crystal differently in my device than the people at Westinghouse. And So I decided that the alignment, the orientation of the liquid crystal created by the substrate was very important. And then the other thing I learned was the first room temperature liquid crystals I could get were lyotropic liquid crystals, which are water soluble, and lyotropic liquid crystals are destroyed by the voltage that you apply to them. So I learned not to work on lyotropic liquid crystals, and that orientation was important. So as a result, I decided to work on field effect liquid crystals, which would not be destroyed by the electric field like the dynamic scattering devices that were made by RCA. And I needed more infrastructure. And so I decided to go back to the US, and I wound up working at Bell Laboratories in Murray Hill, New Jersey for 4 years. And I was hired by Bell Laboratories to work on their holographic optical memories.
Sounds so cool.
My first day at work at Bell Labs, I was called to the office of my department manager, and he said, the holographic memories are not working out. They're too expensive and they're too big, and we would have to have the entire memory for the entire Bell system in the entire East Coast US in one room, in one computer. And the important root of technology is to distributed computing and not concentrated computing. So it'd be better for you not to work in the area that we hired you for. But what were you doing in Japan? And so I told him, this was Larry Anderson, who later became vice president for Sandia, which was the electronics arm of the US nuclear program. So I described my work in Japan, and he said, that's a lot more interesting than anything we would have you do. So why don't you continue your liquid crystal work? So for the second job in a row, I became an accidental liquid crystal scientist.
How do you get the idea that you want to drive it from semiconductors, or it's been thought of before? Is that what you were talking about before? Is it drive by semiconductors?
Well, at NEC, they wanted to make a display device out of this propagating domain. And I had seen the beautiful images at Xerox when they smeared it on a xerographic drum.
That was just static, an image.
That was a static image. And the Xerox people told me liquid crystals were very fast, which was not true. But that's what they told me. So I thought I could smear it on these propagating domains and make a semiconductor addressed liquid crystal display.
Is that an idea you got, or
that was my idea? That was my idea.
That's your idea, and
Yeah.
you thought that would be interesting to work on.
Absolutely. If I could make a semiconductor addressed liquid crystal display. RCA had published a paper just about the same time I had arrived in Japan to work at NEC. And they had published about a dynamic scattering device. And that was one of the first papers ever written about a liquid crystal display. And in that paper, they said that this technology may eventually be made into a full-color TV display. And so that excited the world. But their dynamic scattering device was done with an electric current which destroyed the liquid crystal. And it was based on scattering, which did not have as good an image as a polarized image. And so I decided to work at Bell Labs on alignment, the first layer aligning the liquid crystal, and on field effect devices. And that led to my invention in 1971 of, I had learned that I could make liquid crystal molecules stand up on a substrate. I could make them lie down on a substrate, and I could make them stand up with a slight angle to the vertical. And so my invention in 1971 was a tilted, vertically aligned nematic liquid crystal based on a field effect.
And here, Display Week 2025, we see one of them. We see it showed off.
Yes, absolutely. Yeah, so it took 30 years for this tilted, vertically aligned nematic to be important because people had to perfect integrated circuits, addressing mechanisms, portable computers. There was no need for this device in 1971. The electronics had to be developed. And so I was...
You invented something that was hard to actually use at that time, or to show off?
Well, I made one of the first direct view liquid crystal displays at Bell Laboratories. And my idea was a good application for liquid crystals would be a numeric display, which you could put on every telephone, and it would tell you who was calling. And I brought my idea to the Homedale laboratory of Bell Laboratories and the people who were developing the electronics for the central office. And I told them my idea. And they said, that's a very interesting idea, but our central office will not be able to support that numeric for 10 years. And so I had to go back and do something else. And I made multiple inventions. And then I realized after 4 years that I had a lot of patents and a lot of papers, that it would be a long time before the Bell system would ever use anything I did in a practical system.
Is there often a difference between the status of semiconductor technology and the status of display technology? They need to fit and match to realize a final product that really works?
Yes, absolutely. And I have to remember the name. I spent a career starting at NEC as a liberator and a revolutionary. And I am writing my autobiography, and the tentative title is Confessions of a Liberator and Revolutionary. I was liberating information from electronic systems and making it visible and useful and entertaining for billions of people. And I did it with a revolutionary technology that was a black swan in 1967 and the early 1970s. And so the second part of my title is How I Flattened the World. So my technology, I was a liberator and a revolutionary, created the flat world, the flattened world we live in today.
That the whole world's population loves to disappear into these displays and imagine new new worlds.
And in order to do that, I had to learn how to orient the liquid crystal. I had to apply the right electronic waveform, and I had to be able to address it with the integrated circuits that were available at that time.
And you mentioned the article that was written in was it by RCA or where they said that in the future could be liquid crystals could be used
could be a liquid crystal television.
And who said that?
Well,
and you said it was exciting the world. So was it like a race and people trying to get there?
Well, this was the first important liquid crystal display publication. And George Heilmeyer was the head of the RCA liquid crystal group. And I think he wrote that article.
And is just imagining, or is actually thinking out of evidence that it could be happening?
They had been working secretly on liquid crystals for over 10 years. There was a guy named Richard Williams at RCA Lab who was the originator of that technology, and George Heilmeyer became a manager of a whole group that developed these dynamic scattering displays. And they had created the first room temperature nematic liquid crystals. And so that was a big breakthrough. And so in order to do this, you needed the electronic circuits, the substrates, the transparent glass electrodes, the orienting layer, and the liquid crystal material. And so in 1971, they published a paper. Actually, they introduced the first liquid crystal display product based on dynamic scattering. And so this excited the world, but dynamic scattering didn't have very good viewing characteristics. And the electric currents, which created the dynamic scattering, destroyed the liquid crystal. So the lifetime was not very long.
And is it called field-sequential, or how is it called, the demonstration that they are showing off here that's related with what you invented?
Okay. So what is demonstrated here is the field-sequential nematic liquid crystal, field-sequential liquid crystal.
And it's just, it seems to be something is happening very fast.
Which doesn't require polarizers. So in all the previous liquid crystal displays, I said it wrong. It doesn't require color filters.
Yeah.
So they use a micro-LEDs to to address the liquid crystal with red, green, and blue sequential colors.
As the backlight, the micro-LEDs?
Yes.
And it's
And then by applying a patterned field to the liquid crystal, they create the image, the red, green, and blue images. And by doing this fast enough, 240 hertz, 360 hertz, 480 hertz, they create a color display which does not have color breakup.
and it's so bright.
And
It's allowed for what, 3 times brighter display, or what does it do?
it's over twice as bright as the displays using color filters, because the color filters absorb most of the light. And those are used in virtually all the other liquid crystal displays.
When I film the screen with my camera, I see this little flicker a little bit or something like that is due to my camera's frame rate or shutter speed
Yeah,
or
that's
something.
because of the interaction of your frame rate with the address rate of the field sequential display.
But
So
with your eyes, you don't see any problem. It just looks great.
Yeah. So previously, TIDLPs, the original ones, used field sequential displays using their digital light processing. And some people are more sensitive to color breakup than others.
Isn't there also laser projectors that do field sequential stuff, even full color now and stuff like that?
Yeah.
So it just sounds a little bit magical. That's like line by line, it just goes super fast, and I don't know how it works.
Well, everything has to work. In the field sequential displays introduced at DisplayWorks this week, they create the entire patterned red image, and they illuminate it with red light from an LED, a micro LED array, and then they create the blue image, so red, green, blue, all the 3 required colors. And if they do it fast enough, the eye does not see the flicker and the color breakup. And some people are more sensitive to color breakup than others. But you have to go, so their first products are going to be static displays, which will be very bright with beautiful colors, and where they don't have to worry about color breakup. And then later on, they will introduce full motion displays where they will refresh probably at least 480 hertz.
So it could be like for digital signage, huge displays, very bright advertising, for example.
At first for digital signage, and then later for bright, full color, large screen TVs.
And if I get a 480 hertz field sequential, crazy bright display at home, and I watch movies and everything on it, it's never gonna get tiring on the eyes. Whatever the field sequential effect is, it's just gonna be smooth.
It should be okay for most people.
There are some special people that might be.
Yeah, their eyes are more sensitive to flicker. But at 480 hertz, almost everyone will not see the flicker.
Maybe we can even double that to 960, or what's it called?
Yeah,
Maybe.
right.
It's just more power if you do faster refresh.
Well, you need, in order to refresh this, the displays that are being shown here use, there are two companies. One uses 2.8 micron thick liquid crystal layers. And I got to talk to the presidents of the company and the people that know what's happening. And the other one uses 2.5 microns. And they confirmed to me that they were using my tilted vertically aligned nematic, which is the fastest nematic LCD. There's another faster one, ferroelectric LCs, but they're not using that.
What is nematic?
Very good question.
It sounds like one of these pumps, or what you call it.
Okay, so let me describe that. Liquid crystals, nematic liquid crystals use long molecules. They're longer than they're wide. And in an ordinary liquid, these molecules are rotated and strewn around by the thermal forces. But in a liquid crystal, these molecules attract each other, and they tend to align parallel to each other. And so when you apply a field to the liquid crystal, you can, instead of the tens of thousands of volts that you needed to get a change in the birefringence of nitrobenzene, you can use only a few volts to change the orientation of the liquid crystal. And so a nematic liquid crystal has molecules which, by an intrinsic cooperative attraction between them, they line up parallel to each other. Sort of like when you throw pencils into a box, they tend to align parallel to each other. And that's the magic world of liquid crystals and why they've been important for over 50 years.
Would you like to mention, you were mentioning to me how we did those videos a few years ago, 7 years ago, and you said that some people saw those and they gave you, it helped them in their thinking about your work?
In my write-up, so I received the Legion of Honor Award of Rensselaer Polytechnic Institute, and they had people, historians, who searched the literature and searched for people who've done important work, who also graduated RPI from as undergraduates. And they found a number of references for me, and one of them was your video, and in which I said the liquid crystal could reorient at only a few volts. And they quoted your video in the write-up.
So that's a pretty cool award to receive.
RPI is the oldest school of science and engineering in continuous existence in the English-speaking world. And it is, I received their Legion of Honor Award at their 200th anniversary celebration in this past October. And there are only 94 members of the Legion of Honor at the present time.
Nice.
So only 94 graduates, and so I'm really thrilled to be recognized in their Legion of Honor.
And the other ones are in all kinds of fields?
And in marquee who's who in America.
And in all kinds of other areas, all the
Well,
other.
like there were 4 of us inducted this year. And of the 4, only 2 of us are still living. And the one that was living was a championship hockey player and coach who's in the Hockey Hall of Fame. And he coached national championship hockey teams at RPI and multiple professional teams. And I don't know what his conflict was, but he was not able to come in person. He might have had a hockey game that he had to. But he was one of the most famous hockey players ever to play and ever to coach. And so he was one of the 4. Another one was the commander of the entire Pacific Fleet in the U.S. He was commander of the 90,000 men who protect the U.S. in the Pacific Fleet. And his wife accepted it for him because he had passed away. And another one was a another one was a black. He wasn't a graduate of RPI, but he was hired to create programs at RPI for non-Caucasian students. And he did a magnificent job at that. And he became dean of students at the school. And he made a big difference in the education of minority groups at first, and then all students of all races.
Years ago. Yeah.
Well, he passed away, and his wife accepted the award for him.
And did you mention also there was some other awards you got recently, or the last few years? Something else?
Well, I was inducted into Marquee Who's Who in America. And they reviewed my history and how I progressed. And my last job, so I was 1 year at NEC in Japan, 4 years Bell Laboratories, 11 years at Hewlett-Packard, doing multiple liquid crystal inventions. And then I founded Kahn International, where we became the world's pioneer and leader in ultra-high definition displays. And Greyhawk's products were used in the U.S. Air Force, used it to program communications with U.S. spy satellites from the Onizuka Air Force Base here in Mountain View, California. And they used our display, our soft spot display, to program these communications. The French Sûreté used the same display in a specially built command center 2 stories below the ground in their Paris headquarters. And they used that to monitor all security operations in the city of Paris. And in fact, NBC News featured our display when they covered the summit conference that I think was the original George W. Bush attended. And so we were featured there. And French Telecom used our 12-foot diagonal ultra high definition display to monitor all telecommunications in France. And these were based on Greyhawk ultra high definition displays.
What year was that around?
I founded Greyhawk as their vice president for technology in 1984. And I left Greyhawk. We sold Greyhawk to the world leader in business projection displays in 1992.
Nice.
And then, when I left Greyhawk, I envisioned I couldn't raise money to build an active matrix facility, active matrix production facility in the US. I told the head of the computer group at HP that for $20 million, we would make them a world-class manufacturing facility for portable computer displays. And Paul Ely, the head of the computer group, pulled his pockets inside out and said he didn't have $20 million. He did, but he didn't want to admit it. But
that was 92?
I was at HP till 84, so that was the early 1980s. One of my most important inventions was I had developed a one-line 40-character alphanumeric display, and working with our electronics research lab in HP Labs, we had made what was probably the world's first portable computer. And the HP Calculator division in Corvallis, Oregon, would have been the logical manufacturer of that portable computer. We brought it up to Corvallis and showed it to the engineering manager and marketing manager of their liquid crystal operation. The engineering manager looked at it. This was a small computer. He looked at it and said, "Something that small will never do anything worthwhile." And the marketing manager said, "There is no market for portable computers, and if there ever is, we will enter it." So as a result, I had three major inventions that they didn't commercialize. The one they commercialized, the display that I demonstrated personally to Bill Hewlett and David Packard, the founders of HP, in April 1974, became the basis for the liquid crystal calculators of HP, and the financial calculator using the display that I had invented.
This portable computer, what was the performance? What could it do, potentially, if it was fully developed?
Right now it could do anything.
Like the one you were talking about back then?
Well, it had an IC memory, and it could do simple things. But you had to have a vision of what it could become. And they were not, HP was not ready to invest in such a device. So it would have been a way of liberating information from electronics and making it visible in a one-line alphanumeric display.
It sounds like sometimes you interact with bosses or people that are kind of like naysayers, and they don't always understand what would be great to do, and it's often a problem, right? Let's say, brilliant people want to know what they want to do, but it's not always the boss says you can do that.
Well, one of the reasons I went to HP was they had a need. They wanted to replace the LEDs in their first calculators, the HP 35 and HP 45, and I enabled them to do it. But they told me that if I came to HP, they would introduce a product in 6 months, and they had a group in place in their optoelectronics division that would develop the manufacturing prototypes and enable them to manufacture this display. But the division that developed the first HP01 watch wanted to use my display in the HP01. But the optoelectronics division was making a lot of money selling LEDs to the calculator people. And they decided they wanted to continue making money with LEDs rather than taking the risk of doing the LCD. And I had developed the first long-lived, hard-sealed LCD that could survive the HP testing,
requirements.
The extensive testing. But the head of R&D at OED said, we have much better reliability in our LEDs, and you shouldn't take a risk. So we will sell you LEDs, but we won't sell you LCDs. And so this entire group that was in place in OED had to move into the calculator division, and then HP moved the entire calculator division to Corvallis, Oregon. And only half the people went. Half the people didn't want to go to Oregon. And so the HP01, the calculator watch, was a technological marvel, but it was a market failure. And the reason was they used an LED, which took a lot of power, and you could only
you had to touch the button to see the time.
You had to touch the button, and you could only do that a limited amount of time before you had to recharge the battery.
You had to swap the battery, I guess, or recharge?
Yeah, I think it was rechargeable at that time. So at any rate, I had envisioned an entire information division where you could get information on HPO1 and follow-on products, and there was no internet at the time, but you could plug in someplace in the airport and get an update. And
Envisioning stuff at that time must have been really fun,
well,
because a lot of stuff didn't exist and you could just like imagine it.
well, a lot of stuff doesn't exist now, and right now we have AI. And these displays, my display that is being introduced here, the real-time version, the first product that they show will be static displays, but the real-time version will use artificial intelligence to program the electronic input to the display so that you don't get the color breakup. And so
AI.
it'll probably be 2 years before that's introduced.
Did you imagine this display in 1971?
Well, I've been following the color sequential technology for at least 20 years. And I've been following a professor at the University of, this is the University of South Florida, who has one of the leading liquid crystal display operations in the US, including a large number of ladies who were educated in mainland China in Chengdu and came to him for graduate work. And his students are in Apple and Meta, and they are populating our liquid crystal facilities. And they did pioneering work in these field sequential displays. But it took BOE and AUO to develop the materials which are being used in the products shown here this week.
Such an amazing industry. It takes time sometimes, but it's amazing.
Well, at any rate, so in my book.
How soon can people find your book?
Well, I have to write it.
Are you writing it?
I'm in the process of, I'm learning a lot about publication of technical memoirs. So I want to have not only the technology in there, but I want people to know the personal development that I had to go through in order to stay in the liquid crystal field for 50 years. And
I guess it's also a psychology, and you need to be strong in your convictions to not quit and do something else because it's easier.
Absolutely. Let me give you a quick rundown, but in the book, I will tell people how if you have a new material and you want people to use it, you have to make a device. If you have a device that you want people to use, you have to have a system. If you have a system you want people to use, you have to be able to manufacture it. If you manufacture it and you want people to buy it, you have to be able to market it. And if the company that you work for has a strategic direction which needs this device that you've manufactured, then you can market a successful product. If you're not in the strategic direction, you have to either change the company's direction or change your own direction. And if you decide to change your own direction, and then you have to find another company that has the strategic direction that you want to go in. And then you have to hire people who understand what you're trying to do and are able to market it successfully. And what I discovered at HP, I was able to satisfy the strategic direction of the optoelectronics division and of the company. But in 3 products that I developed that were very important and commercialized by Greyhawk, it turned out these were not in the strategic direction of the company. And so I went to Hewlett Packard. Well, actually, start over again. So at NEC, I started their liquid crystal operation. And this was bought by TVAN. TVAN is here. I was the first employee in the company, the NEC company, that TVAN bought. And so my legacy is living here in TVAN.
Nice.
But they only describe the founding of TVAN in 1983. But NEC's liquid crystal activity started in October 1968. Okay, so anyway, I needed more infrastructure, and so I went to Bell Labs. And after 4 years, I realized that I had to go to a company that wanted the technology that I knew how to make. And that was Hewlett Packard, and enabled their calculators, which the 1981 calculator is still being sold as the longest product-lived electronic consumer product ever marketed in the United States. You can buy it on Amazon. It's not made in Corvallis anymore, but it's manufactured in China. But then my interactive computer display, which I made at the request of the Bubbling computer division of Hewlett Packard, the engineering manager came to Palo Alto and said, I need a large area flat panel display. And I said, I have one in the basement, because I had spent a year to get all the people working on this multi-divisional, multi-group international project involving the Bubbling computer division, the San Diego printer division, the Corvallis LCD activity, and the optical people in HP Labs. And also one key optical guy in the scientific instruments division. And I got them all together in a conference room, 1501 Pageville Road, and they decided to go ahead with the project. They were going to make the manufacturing prototype with all these divisions cooperating. 1 month later, I was at HP. I ran a multi-divisional display meeting on all the different display technologies. And I was having dinner with my boss and the head of the instrument group. An important part of the instrument group was the San Diego division, and they were going to manufacture the hardware. And the head of the computer group, which was half of HP, said, "Fred, we are not going to manufacture your device." And I said, "Bill, why not?" And he said, "I am not going to spend instrument group money for a system that is going to benefit the computer group." So at any rate, so that was failed at a very high level. And so I didn't tell you the story about Bill Hewlett. The optoelectronics division, in order to keep selling their LEDs to the calculator division, kept shrinking the LEDs and using higher and higher power magnifiers to make them visible. And finally, in one product, they managed to reduce the viewing angle to less than that of a liquid crystal. And as was customary, the head of that calculator, the newest calculator of that division, the project manager brought the first manufacturing device, serial number 1, to Bill Hewlett. And he put it on his desk, and he said, "Mr. Hewlett, here is your new calculator." And Bill Hewlett said, "Please turn it on." And the project manager said, "It is on, Mr. Hewlett." And so Hewlett rotated it slowly until he could see the display. And he realized that finally they had made something that had less viewing properties and required higher power than an LCD. And he made an executive, very soon after, he made an executive decision: there will be no more LED calculators at Hewlett-Packard. We will only use LCDs. Unfortunately, before this portable computer and my interactive large screen display for Bublingen, Mr. Hewlett had retired, and there was now a MBA John Young in charge of Hewlett-Packard, and Mr. Hewlett was not there to pioneer my technologies. So it required, so the decision on changing from LEDs to LCDs was an executive decision of a technically knowledgeable manager who was ready, who recognized the importance of changing direction. And that no longer existed at Hewlett-Packard. So I had to found Greyhawk Systems as a company that was strategically where we were strategically oriented to develop a company that were selling products based on advanced liquid crystal displays. And we had not only the ones I mentioned to you, but we had Sharp, DuPont, International Paper. They were partners with Greyhawk Systems in developing products using our technology. And then finally, there was a revolution. Excuse me. There were 2 earthquakes in 1989. There was a physical earthquake in Silicon Valley, and it displaced, well, it killed 63 people, and I think 3,000 people were injured in the physical earthquake along the Loma Prieta Fault here in Silicon Valley. And I missed that earthquake because I was in Japan attending an international display conference and the Japan Electronics Show in Kyoto. And when I tried to raise money to make active matrix addressed liquid crystals, the technologists here and my managers at HP said, that's too complicated. It will never yield a manufacturable device. And at the electronics show, I witnessed the electronics earthquake, where Sharp demonstrated 3-inch diagonal TV quality AM LCDs, and they had shown that they could make 40 of these with good yield and no pixel defects. And I went back to the US and I tried to get the president of Greyhawk, because I was only in charge of the technology. I tried to get the president to change direction, and he didn't do that. So that's when I founded Kahn International, which helped all different companies, starting my first client was the executive committee of Intel. And then Hitachi got me to write a monthly report for them, and I decided I could write a better report for Hitachi if I had more clients. And so for 15 years, I did the Kahn International multi-client report on, Kahn International report.
I think it was like a publication?
A monthly publication. It was the Kahn International report on, was a multi-client report on display technology and markets. And I realized I had to have at least 4 clients, and I wound up with about 15 who were subscribers. And I did that for 15 years, monthly report. And then Kahn International, I worked for Kahn International for 29 years, and which was very unusual for a technologist to be able to continue working on the next generation technologies for such a long time. And that's how I wound up in Who's Who in America.
I just need to stop the video because it's about to
I'm sorry.
overheat the camera. My camera is too small for this length of a video.
I'm sorry for...
No problem. So
I hope this is useful for you.
no, it's very, very useful. And there's also, you were mentioning a notebook LLM link. I'm going to put it under the video here, and it's on your LinkedIn profile.
Yes.
It's from a Sri Peruvemba article analysis into a podcast.
Yeah.
You can listen.
Sri Paravamba used Notebook LM to turn his article into a podcast.
Yeah. So that I'm going to link to that one.
Yes. So,
And-
so you can read the article, but the podcast brings out the personal aspect of my career.
That's cool. All right. And people can look forward to your autobiography coming out.
I hope so.
And you just have to make it, right?
Absolutely.
Yeah. And
So-
I will link to our old interviews also. And
I did a keynote address in 2016, which describes my history and liquid crystal display history from 1967 through 2016. And I don't know where that's accessible, but I have it in my computer.
all right, if you can find it, I will link it also under the description.
Well, no, I'm going to preserve that
Okay.
for the biography.
Autobiography. Okay.
Yeah.
Cool. But thanks a lot for this interview.
Well, thank you. I appreciate your interest
Cool.
and your continued due diligence.